Recording has started.
Okay, cool. Okay, hi everyone, welcome. Thank you for joining us for today's webinar. Today, our focus is conducting autonomous inspection with Mavic 3 thermal and Volateq software solution. My name is Irving. I'm a solution engineer from DJI Enterprise, the professional branch of DJI dedicated to provide solutions to our professional audience. I'm very delighted today to have Chris and Fabian from Volateq as presenter with us. Welcome. Okay, next I will shortly share our agenda for today. First of all, I will give a brief DJI solution introduction. It will take like 5 minutes. Then we will have our guest as presenter to share their solutions. And in the end, we will have a Q&A session. Just a little housekeeping before we start. First, this webinar is being recorded and will be made available through a link later to all the participants, but also to the people who registered but couldn't make it to the session. And second, after the presentation, we will have a Q&A session to answer all the questions. So we invite you to drop the questions in the chat box, which we will take time to answer in the end. Now, without further ado, we will turn the time to first DJI presentation. I will start to share my screen. Can you guys see my screen? Okay, cool. So let's get started. Conducting autonomous inspection with Mavic 3 thermal and Volateq software solution. So firstly, maybe we should start from the industry. Due to three major drivers, favorable policy and high investment enthusiasm and fast-growing technology, solar industry is growing very fast. And as we know, it's very hot in Spain, in Europe, in all the European countries. I mean, the market is big and very potential. And here I also put a picture of our European Commissioner for Energy, Kadri Simpson. She said that by 2030, the share of wind and solar energy in power production capacity should double from the current level of 33% to 67%. So that's a big potential it shows. Okay, and let's get to know more about the market development. First, I will give the conclusion. Drone inspection market has huge potential in solar industry. Please everyone check the graphic. Here is the timeline, and here is the market development gigawatts. As we see from the graphic, we can know the European solar power generation fees increased by 25% from 2021 to last year, which is more than 289 gigawatts, which is a very big number. Maybe lots of our audience, they are drone experts. They don't really have the understanding of the gigawatts. Maybe I will translate a little bit. It takes more than 80 flights if we do inspection with the drones. So it's a very big number. Okay, let's get to know more challenges of the customers in solar industry. First big challenge is it's a really risky job. The workers the inspector always need to get very close to the solar panel, which is very dangerous. And second point, if we are using the hand holding equipment, it's always be very low efficiency and dangerous. Yeah. And the third point is the big ground-mounted station is always far away from the city and always based on the mountain or on the lake. It's always hard to access. It's also a big problem for our customer. And fourth of them, is that there's no assets health management system for customer. So based on those challenges, what is drone's value? So I will also give the conclusion in the beginning. Drone can help to increase the efficiency and save the cost. So please, may I have your attention here? From the table, we can see I selected 4 sites with different size. And we can calculate the drone inspection time and the manual inspection time and their difference. And from the difference, we can calculate the efficiency increased and net cost savings. So the final conclusion is, if we are using drone to do the inspection, if we compare with manual, we will increase our efficiency of 97%, and for average of $1,254 per megawatt for the cost saving. Okay, then let's talk about the different generation of the drone using. The traditional way, as we said on last slides, is kind of risky and low efficiency, hard to access, no health management system. And based on those challenges, if we purchase a drone to do the high efficiency inspection, let's say we will go to the digitalization first generation. So using the drone is a very, which is very friendly price, and have very accurate the sensor, and our big drones is really multifunctional because we can change the payloads, also very strong performance. And after that, DJI provide DJI Dock in this year, which is automated inspection solutions. DJI Dock enables automated and digital O&M platform for solar industry customers. It provides the opportunity to take off, do the mission, and return back, charge himself, and send all the data with the thermal images and the temperature information to your computer while sitting in the office drinking the coffee. Okay, that's pretty much from my part, and I will give a little bit more introduction of today's our speaker, Chris from Volateq is a co-founder, and Fabian from Volateq is product development manager. They are experts of the solar industry. They have various drone experience and their software development experience to share with us. So welcome, Chris and Fabian. Are you ready to start your parts? Okay.
Yes, thank you for the introduction, Irving. Fabian, I'm going to share the screen so you can continue with the introduction.
Thanks. Thank you, Irving. Yeah, for the kind introduction. So as you rightly said, we're going to talk about our solutions to provide autonomous inspections with the Mavic drones.
Do you see
our software.
Do you see my screen now?
There.
Okay.
Yes,
yeah,
yes.
Correct.
To use our software with the DJI products and how to perform these inspections. So I'll present the agenda later. But on the next slide, I'll just introduce ourselves. So we're Volateq. We're a German Aerospace Center spin-off. We were founded in 2020 with the knowledge gathered in our previous work at the German Aerospace Center. We provide software as a service solutions for inspections of utility scale solar power plants, so big solar power plants. We serve, and that's 2 types of solar plants. So we serve photovoltaics and concentrated solar power plants. I'll come to the details later. Maybe some of you are not familiar with the concentrated solar power. I'll explain the technology in a minute. But we grew up there, so to say, and we already serve 25% of the global installed capacity of CSP. And we went into the PV market, which is also my responsibility here at Volateq. And we have a strong focus on innovation, high level of automation, higher repetition rates, which are due to our history also in CSP. We can provide fast data processing and have a focus on the user experience, so ease of use of the whole workflow. So on the next slide, I'll present our agenda. So first, as I said, we're gonna introduce you to the two technologies, CSP and PV, then analyze a little bit the market potentials in both markets for inspection solutions, then go into details, technical details. How do we actually detect failures in CSP and PV? Then present the workflow. So what do you have to do step by step to work with our product? Present some use cases and how we later present the results that were produced in a measurement campaign to our users and customers, and then go into Outlook R&D, what we're actually working on, and the question and answer session. So Chris is jumping around. Go to the next one. So first of all, introduction to the technologies. On the next slide, we're going to have the characteristics of CSP technology. I think you can start the video right away, Chris, if that works. I hope that it's coming across. So you can see on the left hand, you can see a video that makes it more illustrates the technology. So here, the direct sunlight is concentrated onto a tube, usually in parabolic trough concentrators to high temperatures, up to 400 degrees C. There's a thermal fluid there that transfers that heat into a steam cycle to run a turbine. So you can see the heat exchanger here. Then the heat goes to the steam cycle that runs the turbine and then provides or produces electricity. That's not the only use of CSP. And the good thing about CSP, one of the main advantages you can see here is the storage tank. So you can store that heat fluid in thermal tanks, in a hot and a cold one, hot storage and cold storage tank. And at night, you can keep on to running the turbine when PV or photovoltaics and other technologies are offline. CSP still is able to produce heat and electricity, of course. So that's one of the main advantages, because the storage is also very cheap for that technology compared to batteries, for example, or other types of electricity, direct electricity storage. Thermal storage is much cheaper. Of course, you can also use the heat directly as process heat. And it's foreseen that CSP has a big growth in the future once the need for dispatchability in the electricity market grows due to the high penetration of photovoltaics, and also industries looking to decarbonize their heat demands. And apart from that, those power plants look very neat, and in many movies or images on sustainability, you can see some images of mirrors. So let's go into photovoltaics. Yeah, that was good already, Chris. The global installed capacity is a lot bigger in photovoltaics, so more than 100-fold that of CSP, due to much easier installation, much more application cases, and you can use and apply this technology in a broader region of the world. So CSP is more or less limited to the Sun Belt, where you have a lot of direct irradiance and not so many clouds and stuff. And PV, you can apply it everywhere, basically. About 50% of PV globally are utility scale, so that's the target of inspection software and big scale inspection solutions. So half of that market can be accessed by companies as us. And of course, growing rates have been high during the last years, and continue to grow. And it's expected to continue that way, because you have many application cases around the world and in buildings and everywhere. So and it's cheaper, already cheaper than oil, for example, and coal in many cases. Good. So next slide, please. Yeah, as I said, we're working with both. And now we're going to go into the markets, and that's something that Chris can present.
Okay, so I'm taking over here. Let's first have a look at the economics of utility scale solar power plants. So usually they have a certain amount of full load hours. There's a certain price electricity is sold to the market. And under these assumptions, we see that 100 megawatt plant can generate revenue up to 25 million euros per year. So all these plants have potential low performing areas. So assuming that, for example, by drone monitoring, we can harness a 4% efficiency gain and that we can reduce operation and maintenance costs by using drones instead of personnel and by enhancing the safety, like in an extreme case, the revenue of these plants or the benefit can be enhanced by more than 1 million euro per year. Well, but an average typical values for optimization potential with drones for solar assets are 500,000 for CSP plants because the technology is mm, a bit more complicated due to moving parts and heat transfer fluid. But still for PV, there's a 200,000 euro per year that can be harnessed or lost if drone inspection are used or not used. What might be interesting for the audience is the size and dynamics of drone-based condition monitoring. So we are not talking about the electricity generation, but only about the market for drone-based inspections. For the CSP, it's rather small because it's only 8 gigawatt installed worldwide. For PV, we have currently 1.5 terawatt installed, and with the already mentioned 20% growth rate, we expect the market for drone-based condition monitoring to exceed 1 billion by 2030. And if we are focusing only on utility scale plants, like several megawatts or bigger, it's still 0.7 billion euro. And as you all know, there are infinite use cases for drone inspection, whether it's linear infrastructures or critical infrastructure. So we found some numbers stating that by 2030, considering all the application of drone-based inspections, this market might be even bigger by 30 billion euros. Let's have a look what is the customer benefit if he takes aerial inspection software, especially if it's software as a service. Before that time, your solar field might be a black box. It might be well or not so well performing, but you don't know why. So you gain clarity. You save a lot of resources by using our software as we hand over the drone flights with a high degree of automation to the plant operator. You win autonomy. And in the end, you will improve the performance and increase the profitability of your asset. In the next slides, we will go into some details to state what actually can go wrong in CSP and PV plants respectively, and we will highlight some of the potential failures that can be detected and then solved by drones. First, for the CSP plant, it's really like big plants where large mirrors are harnessing the solar energy and transferring them to the power block. In these plants, there are mirrors that are concentrating the solar radiation onto a tube, and these complete collector is tracked following the sun so that the radiation always is hitting this tube. And you can imagine that this is a high precision optical instrument. So the shape of the mirror is responsible if a reflected sun ray is really hitting and absorbed by the tube or not. And with our software, we can check if the shape of the mirror, which is parabolic, really matches the design criteria. Next point is that this tube is supposed to be located very exact in the focal line of this concentrator. Here we have developed methods to check the position of the tube. From very high flight altitudes of 120 meters, we can cross-check the tube position relative to the focal line with an accuracy better than 5 millimeters. Next, the typical issues in CSP plants is sometimes the mirror break due to wind or impacts from the cleaning trucks. So this is also an issue that is important for the operator of the plant to know. In some plants, we have weekly drone flights to check with less than half an hour, we can have a complete check of several square kilometers of the solar field to track the mirror status. Another important issue is the concentrator alignment. These concentrators are very long, up to 200 meters, and must be very well aligned. So we also can tackle any misalignment between the single modules of the concentrator with an accuracy of up to 0.0 degree. In the image below, on the right, you see that we are working with the enhanced reflection of the absorber tube, and any disturbance of this reflectance, you can intuitively see that there must be something wrong with the geometry. Well, it's solar thermal plants, so the heat is collected and then transported to the power block. So during the way of the heat transfer to the solar field, you want to avoid any thermal losses. For this, these tubes are not just simple tubes, but it's a steel tube inside and the glass envelope tube around it with an insulation of vacuum. And the status of this vacuum must be checked regularly in CSP plants to see if the thermal performance is according to the design criteria. And this can be done with the infrared camera. And last but not least, there are some safety relevant issues that must be checked daily. For example, any leakages or forces of rotating parts and blockages. And for this, we have like special flight routes to have high detailed checks and images and videos to see these failure patterns. Well, all these different performance indicators can be combined in different product packages, and we also offer different intervals where the frequency of the checks depend a little bit on the dynamics of the failure. For example, if you want to use to check the mirror breakage, or for example soiling of the solar panels, you would go to higher measurement frequencies, while for example the concentrator geometry itself is something that's rather static, so it's okay if you check this once or twice a year. So I will hand over to Fabian to present similar issues for PV.
Yeah, thank you, Chris. These are a little different, but we mainly use the infrared camera for PV inspection because, as a general rule, if something goes wrong in a PV field, that appears as a higher temperature on the modules, basically. So that is the major rule here. But one of the main challenges here in PV is, of course, to identify and geolocate the individual panels within the solar field. So that's the first step, which you can see here on the left-hand side, where it shows like two example images, original images of the infrared camera taken with a Mavic drone. And there we first of all, we identify the modules in the field and relate them to the digital twin, which has been created before the flight. And then we have each module appears in several images. So it's like 5 or 6 images per module that we gather, and we crop those modules from the original image. So we get a stack of images, which is the second step here for each of the modules. So you can see the module number, which is an example here. And then you have several images for each of these. And then we run the thermographic failure analysis on these images, and then can see if a module is like has a defect or if it's okay. And then we create a list of failed modules and those that are okay. And then we can map this and visualize the results in our web application on the map again to give the user true image of what's wrong in his solar field or not. So in the next slide, I'll go into step 3, which types of failures we can detect and what can go wrong in a solar field. On the left, on the top here, you can see a hotspot, which is basically the most known error type. So one cell within the module is heated. It has a higher temperature because it has a failure. That's a clear indicator usually. So we can detect that automatically and then categorize this error as a hotspot error. And on the right, on the bottom, on the bottom right of the image itself, you can see a module that has obviously not been connected within the string. So there's one module that doesn't work. It appears as a higher temperature because it doesn't operate or it doesn't produce electricity. On the left hand, you can see some shaded modules and what happens if you have one module shaded by trees, which are adjacent here to the strings, is that the rest of the module string heats up because it doesn't operate at the maximum power point in this case. So that's some other error types that we can detect here. On the next slide, we can see another one. Like we always have to double check with the original visual image, RGB image, if that error type has been detected correctly. So on the left, you can see a normal hotspot. So in infrared, it looks like a normal hotspot. But if you do another click, Chris, then double checking with RGB, we can see that a bird has left his traces here on that module, and fading is thrown onto this one cell only, and the same effect happens as with the shadow of the trees. So that's not an actual case to exchange the module itself, but you only have to clean it, so to say. And so the double check is really necessary to exclude false positives here. On the right, you can see one very specific case where a row is colder than the rest of the rows, and that throws us an error in post-processing, and we have images ourselves. In this case, we saw that just a cleaning machine has passed by before, which is an exception, and we can say that these modules are, we suspect that these modules are okay in any case, and just the water of the cleaning has cooled them down. So on the next slide, we can see another detection method that we derive from visual images, from RGB images, and that's the soiling ratio. To our knowledge, we're the only ones offering this product, and we quantify, or we provide a quantitative value for the soiling on cell level. So on the bottom, you can see a distribution of the soiling over one table or one string of modules. On the bottom row of this image here, some modules have been cleaned for testing, but the color, as they go more into red, they are more soiled, and you can see a clear pattern, which is pretty typical and has been seen in this specific case also by the blank eye, that the bottom row of cells has been soiled much more than the rest of the cells, and that of course causes some, for the experts of you, that causes some mismatch effects and causes the actual loss, energy loss, to be higher than the average of soiling loss that you would detect over the module. So we can detect that in very quick flights, taking videos over the entire field for the entire solar field. So you get a soiling value that is much more complete than just having a soiling sensor somewhere in the field. And from that, we also use that, of course, to have a double check of hotspots. So we provide in PV, we provide 3 basic packages. One thermography at low flight heights according to the IEC standard, then one which is more practical at higher flight heights, so 40 meters more or less, that gives you the quick checks of the solar field, which are sufficient for most operators. And we also provide the soiling product, and you can choose between different flight repetition rates, and also we're working on the drone in a box solution, but I'll have a slide on that later. So yeah, that was the overview of our PV products. And I'll hand back to Christoph.
Okay, so now let's check next the data acquisition and processing workflow. So the first step is that we need a digital twin of the asset. The digital twin is the basis for the analysis and also for the design of the flight routes. Once we have that, the drone follows its pre-programmed automatic flight routes, captures the data. The data is then uploaded to our web app, analyzed with our software, and within several hours, our customers get results again in the web app as a map or as table view for where normally like problematic areas are highlighted with red color. The first challenge that we are facing is like how to get the solar plant, how do we get the digital twin? We can use, for example, drawings, but experience shows that there is a difference between drawings and as built status. So normally we do our own 3D scans to distinguish like the modules and trackers from each other and create a digital twin. And the most simple solution, which has worked very well for us, is using just Google Earth and creating our custom KML files and from there the digital twin, because normally there are not so many earthworks necessary, and we get impressive good digital twins just by using Google Earth data. But then the plant needs to be like older than a year or two to appear in Google Earth. Then we end up, as shown on the right, with a copy of the asset with the different component hierarchies of in electrical interconnections, combiners, strings, trackers, and modules. For the data acquisition, we have different like flight patterns and characteristics for concentrating solar power and PV. They are quite different from each other. For PV, we have typical flight heights between 15 and 40 meters, depending on the desired resolution. Flight speed is always limited because the microbolometer of the infrared camera has a fixed kind of exposure time of 100th second. So we want to avoid blur, so flight speed is limited. And we need a certain overlap to make sure that each module is covered from several perspectives to avoid kind of sun reflections and suboptimal perspectives. For the CSP is quite different. We work with videos because we need a very high overlap of the images of more than 95%. In the same time, we can have higher flight speeds and higher flight altitudes because we have our own method to work with the absorber reflection. So even at high altitudes, we get sufficient information. For the automatic flight execution, we are working with DJI Pilot or DJI Flight Hub and also with Litchi. But after some time, we noticed that these apps are they are really good, especially like the DJI Pilot, because you have access to all the settings. But our customers are not professional pilots, and sometimes they start getting confused by the number of options they have. So based on the DJI SDK 4 and 5, we have developed our own very clean and simple Android interface that only provides the option to select flight routes for a specific plant and execute these flight routes, while all the settings are written in the background and are not accessible to the user. We exclusively work so far with the DJI prosumer drones. So we are quite convinced that having small but powerful hardware and payload is enough for these kind of inspections. Especially the DJI Mavic 3 and 2, the previous module, they have a very intuitive and easy handling. They are cost effective. They are worldwide available, and normally with these rather small drones, you have no issues with flight permissions. Still, they have very good payload specifications regarding the infrared and the visual camera. And if you have any problem they are available and you get like a good service. I think you are all familiar with the different specs of these drones. What's especially an advantage of the new M3T is the enhanced flight times of up to, I think it's 45 minutes. So there are less battery changes involved to scan a full solar field. As soon as the data acquisition has been finished, our users can create new analysis and upload videos to our web app. I also want to provide some information on our experience with drone legislation, because we have been active in many countries, among others in the European Union, Morocco, Israel, South Africa, USE, and UAE, United Arabian Emirates. And we have made different, we have had different experiences, how easy it is to get a drone flying by a customer. The good thing about the EU is that in all the countries you have more or less the same rules for a large territory, and you have a pilot license, for example, in Germany. Theoretically, you can use the same license, for example, in Spain or any other country. But as soon as you are facing a restricted airspace and you need NOTAM, you need to deal with national authorities. And another issue is that BV laws permissions and permissions for drone in a box system is still not a standardized process. So you need some patience until you get these permissions. Morocco is quite straightforward, but locals say it's rather easier to get a gun than a drone legalized. So here also permission process is quite long. Israel was quite straightforward, South Africa also, but to become a pilot is a very time consuming and expensive process. Well, the most difficult country for us was the UAE, because their flight permissions for some political reason have been very restricted. But right now, I just was in the UAE to onboard a customer there, and it seems to work now. But any country is different. In the next point, we will show 2 use cases where we had successful projects. As you already see with our experience from flight permissions, we are active globally in different continents and countries. So here I want to highlight 2 projects. The biggest one that we had was in the USA. The plant name was Solana. It was a 280 megawatt CSP power plant with 6 hours of thermal storage. The objective of the customer was to have an overall solar field health check to see if anything is wrong in the solar field. This analysis was carried out one time. It took us approximately one week to acquire the data, and then like a month to evaluate it all. And the data acquisition was carried out by an external pilot from Las Vegas, who was doing all the paperwork for us and also flying the drone. A different use case is a plant called Ilanga by the company Stereotype in South Africa, close to Uppington. It's a bit smaller, like 100 megawatt, 5 hours. For this plant, we have like a very high measurement frequency of monthly and now bi-weekly flights, where a certain degradation process is monitored by the operator, and it's also important to verify if any countermeasures that are done to maintain the performance of the plant are effective. So this project has started in 2021, is ongoing, and the drone is flown by the plant operation team. The next step would be to see have a quick tour through our web app. So I will quickly leave the presentation and switch over to our web lab. So we have a demonstration plant here Our web has the option for the customers to see different plans, analysis. We also have documentation as a wiki, where users can find all the information on drone flights, camera settings, and so on. So let's have a look at this demonstration plant. What you see here is a digital twin of the plant, so with different components. So a plant, in this case a CSP plant, usually consists of loops, collectors, mirrors, absorber tubes. So all these components can be shown. On the left side, we see different types of analysis. So if a customer, for example, does a scan and another, we can have a comparison between these analyses. In addition to the map view, there's also the table view, and statistics can be shown how different performance indicators have changed over the time. And going back to the map view here, for example, we can have a look at different components. Again, the absorber tubes, mirrors, collectors, or modules. For the PV plant, the components would be quite different. But in the end, for example, if we have one parameter like the absorber tube, what can happen is that there is a glass breakage. And if we compare, for example, two analyses here, we would see the difference in terms of what has remained in the same state and what has been fixed in the meantime, or what has broken, what is another damage that has occurred. I think in order to stay within the time, I would stop the demonstration of the web application here and go back to the presentation. So I would hand over again to Fabian to provide a summary of this of our presentation and give an outlook on our R&D activities.
Thanks, Chris. Yeah, let's just put it all together, what we presented now. So we actually try to enable our customers to perform their drone measurements with the highest level of independence. So they can work with their own personnel if they wish so. And they don't have to call in like external pilots and service providers. Chris, you should click one more slide ahead. So yeah, thanks. So that gives them the highest level of autonomy, flexibility in terms of when they want to perform the measurements and how often. And of course, it cuts the costs. And therefore, we need a high level of automation, which is one of our main goals here. We try to provide the highest level of comprehensive, actionable reports, as you've seen in the web app, and what's behind there, like how do we produce those results. And yeah, our software solutions can be applied by anyone in the field, like it's usually normal field staff that works with us and operates the drones. And we actually, yeah, design the flight routes and do everything else. So the operator just has to watch the drone fly and start it, of course. So it should be an all-in-one solution, and it's globally available. So that's what we offer currently. And in the next slide, I'll have an outlook on what we're planning to do, or where we're going. I mentioned the drone docks. So we're working also with DJI on testing a drone dock in a concentrated solar power plant here in Spain. Also because the CSP customers, they really are eager to have a drone dock because of the higher flight repetition rates as compared to photovoltaics. Although we see in photovoltaics, if you have a large plant, or if you have high soiling rates or high degradation rates, then a docking station might also make sense. Also, maybe talking about security and on-demand inspections to have from your office seat an a closer view on parts of your solar field. There we also see application cases here. And maybe in the future we could have the drone as a colleague which you just carry with yourself on a vehicle or something, and it does its work independently. So, but that's the vision for the future. And apart from that, we're working in the field of agri-PV to combine thermography and crop health monitoring, also biodiversity monitoring, which are topics that are coming up in photovoltaics. We have a research and development focus, so complex geometries, desert climates, that's where we feel familiar. And if ever anyone in the audience has any specific needs of new applications, then we're happy to help. And we're looking for partnerships and cooperations in the energy sector. So if you have some application cases, please don't hesitate to come up to us. So yeah, I think that's all from our side. I think there was the team overview here. We're growing, so there's not pictures of everybody, but the main our main employees here. And then I'll hand over to Irving to go to the question and answer session. Chris, you can show the next slide. There's our contact details also, which will be shared, I think, in the mail after the webinar. Great. So Irving.
Okay.
Thank you.
Thank you, Chris and Fabian, for the very fruitful and interesting sharing. I also learned a lot. And one quick question from me. Are you guys planning to do some integration between your web app and DJ through Cloud API, DJI Cloud API, to do the integration with DJI Dock? Because recently we just released a new version of the Cloud API, and I think it's a new opportunity in our cooperation. If you want to provide the dock solution for our customer.
Sure, I think we had a look at the Cloud API a year ago, and it seemed feasible. And if you say there is now an update, and as we are already familiar with the SDK, I think that's an option for us to have this integration. Sure.
Yes, and recently we just add a new feature on the Cloud API that's I don't know the English translation, but it's similar like cloud integration. So our customer can use DJI FlyHub 2, but the data will proceed in Volateq, in your web app, and also in your platform, in your beta days. So I think it's a new opportunity in our cooperation.
Okay, cool.
And yeah, and maybe later I can also introduce you guys to join DJI ecosystem list. Okay, so thank you again, and we will start to answer all the questions. I already did a little bit summarize. The first question is, what's the drone operation license required to fly autonomous drones like DJI Dock in Europe? So I believe this question should be answered by me. Actually, we are parallelly start several BVLOS applying a program in Europe. It's already start it was start 3 months ago, and in some of the European country we already have some results. We already successfully applied for Cell 2 BVLOS, and we already get the approval. So basically, if we are using DJI Dock to do the autonomous operation, we need to apply for the beyond visual of sight, which is BVLOS I mentioned, to normally proceed the operation. And to get the BVLOS approval, you need to issue a specific how to say the workflow. There's some very specific introduction on YASA, and maybe later I will share with this audience the link how to start the BVLOS approval from the first step. Okay, and the second questions, does FlyHub 2 support geofence, which is no-fly zone or operation area which fence the drones to an area which we don't want to fly? Yes, actually, it's a very good point. We just added in this month in DJI FlyHub 2, you can set a geofence, like you can set a set by yourself a polygon that you don't want to drone to fly in, and you can also set a how to say, green fly zone that you only want your drone do the operation inside of this circle. So like self geofence will be added in FlyHub 2 in this month. Okay, and the next questions. Can we have the slides? Surely, after our sharing, we will send the slides and the record to all the attendees. And could you also share the contact detail of Volateq for partnering? Yes, of course, we will later put our partner Volateq's contact for everyone to know it, to have the contact, of course. And Fabian, I have a question which is in Germany. I will send it here. Could you help
Yeah,
to
I'll
answer?
see it. I just read it also. So the question is about how we plan the flights, or how it's supposed to do the flight planning, and how the flights actually are performed, like in the middle of the rows, or in which height and in which distance from the modules. I think that refers to PV, so photovoltaic. The flight planning is done entirely by us. So we, based on the digital twin, which we have to create before the first flight, we create those flight routes according to the desired time when you want to fly, and then you receive that flight route either via our Volateq app, or via Ligi, or other means of flight controllers. And then you just basically, as an operator of the drone, you basically only have to select the flight route at the right time, and then push the green button, and everything else is done by us. So we actually fly in a right angle over the modules, but it doesn't really matter. So you can also fly along, but we have more experience with flying perpendicularly to the rows. The flight height depends on the product. So if you want to fly according to the IAC standard, the flight height is something around 20 meters above the modules, or distance from the modules, and we look down perpendicular onto the modules. So it depends on their inclination, how you have to look down on them. And that's all done automatically. I hope that answers your question, Dietrich. I think it was, yeah.
Okay. Thank you, Fabian. And I also have a quick questions regarding the very big overlap during the video. I want to know behind your software, the process, like how you guys break down the video. You will break down into several different separate photos to do the thermal analysis. Am I right? So you will break down from the video into the thermal images and to check, to do the analysis from the images.
In photovoltaics, we're working with images actually. So there we use the images only for the soiling analysis, because we aim to have it as quick as possible, and we only use RGB images. But in concentrated solar power, we are using video workflow, and there we actually take all the frames. Is that correct, Chris? No, of the infrared, we take all the frames, no, of the video, and then basically create images out of each of the video frames, and then continue to work with those.
Okay, thank you. Very clear. Does anyone still have more questions? Looks like we covered all of the questions. I think we are good now. Okay, so in the end,
I see.
there's
Sorry,
still
Irving,
one.
I see one more. If we want,
Thank you for
like, that's
thank
a
you
pretty good
for
question.
reminding me. Please.
No worries. There was a question, so that we want to make the drone service providers like superfluous in solar fields, so that the owners can do these inspections themselves. Well, on the long run, of course, but it depends on the owner. Like, if you have personnel in the solar field, it gives the freedom to the owner to decide if that personnel, if he wants to train their personnel to make those inspections themselves using our software. But we can also be useful for the drone service providers themselves, because we can save them a lot of time in flight planning and also in the evaluation of the images. So that's what we take off of them, so they can have a higher throughput of, they can service more plants in the same amount of time. So it's just, we don't want to get rid of the drone service providers, but work together with them, basically make life easier for them. Hope that answers the question.
Is there any more remained questions?
No, there was one that I saw now, but no.
Okay, Fabian, thank you for adding me. Thank you.
No worries. Thank you.
Okay, so in the end, we would like to thank you all the attendees for your time and interest. And we hope that the experience shared today was useful for everyone. And we conclude this webinar. Wishing you have a nice day and see you next time. Thank you. Bye-bye.
Thank you. Goodbye. Have a good time.
Also,
Bye.
thank you, Chris and
Bye.
Fabian. Thank you for sharing.
Thanks.
Bye-bye.
Bye.
You stop the recording?